think before I speak about the company, I would like to say about the cement sector, how this is the most energy efficient industry across the world. We are earlier 4-5 years back we were second to Japan. Now we are the best in the world in terms of energy efficiency. And if you look into the India, India produces approximately 350 million tons of installed capacity per year, and whereas the production is around 250 million tons of cement production. And 97% of the plants have adopted the most energy efficient dry process technology, and still 3% of the plants, because of the limitation of the raw material quality, still operate the wet and semi-wet process. And in terms of the benchmarking, if India wanted to see that where we are, what is the best in terms of India's current average energy is 85 units per kilowatts per ton of cement and 725 kilocalories per kg of clinker. This is the thermal and electrical energy what the cement industry consumes. This is India's average. And if you try to see the India's best plants, you say that it is 684 kilocal and also 65.5 units is the energy. So you can see that there is a 20 units gap, the best unit to the national average, and also the same thing in terms of 40 kilocalories between the national average and the best part of on thermal energy. Similarly, the CPP, many cement plants operate with the CPPs in their plant because of to ensure their power security for the plant. And there also there is a large gap, bandwidth is there in terms of the heat rate of the plants. And also in the auxiliary consumption, what we use, there are plants which is 14%, there are the plants which are using 5.5%. This indicates that the national averages and the best plant and the worst plant, there is a large bandwidth. This is actually the opportunity to improve the energy efficiency for the entire sector. So, and also if you try to see the best reported numbers of the Japan, which is 651 kilocal per kg of clinker and 57 kilocal for the units per ton of cement. So we try to see these numbers that indicate that the sector is having a lot of potential to bring down the energy. So this particular initiatives, each company has done that, and I'd like to say what ACC has done in the last 4 years. ACC is having 17 plants with 30 million tons of the capacity, and you can imagine that 1 unit of electricity, if I reduce, it is a 30 million units into 5 rupees per unit is 15 crores cost reduction for dropping 1 unit of energy. So this indicates that the amount of financial impact it can create for attempting on it. So we have a wide all India footprint. If we try to see the ACC's the baseline numbers, we have the entire specific energy numbers, what is the target, what we got. And would like to say that in this 2011 to 14, we could achieve 8% reduction in over the baseline values. We have exceeded the beyond the benchmark target. This is based on the 31st of Jan data, and we are hopeful that these 2 months, of the last 2 months, we are hopeful that we will be able to reach to 9% of the reduction over the baseline against the target of 5% and 5 to 6% values. So the reduction of the CO2 also we could bring it down from 538 to from 550 to 538, and also we could if you try to see the CO2, maybe close to 33% of CO2 per ton has been reduced. Now I'd like to explain the whole thing of the initiatives in this single slide. That if you try to see what are the levers which are available for cement industry to bring down the its specific energy intensity, is one is about the clinker factor. How much of clinker you use in per ton of cement? Because clinker is the one which is energy intensive. If you are able to reduce the clinker content in the cement, you will be able to bring down the specific energy consumption. So there it involves in terms of product innovation. How you will be able to improve your product quality, which allows you to add more amount of slag and fly ash. So this is one big lever for the cement industry. And the second one is the products which we are going to produce should have the more amount of substitution materials. And so there are the special products have been introduced. So substitute the OPC, which is actually uses 95% of the clinker and 5% of gypsum. If you are able to come out with the products which is having a higher substitution rates of the other materials, of the waste coming from the other industries, there is a chance to reduce your thermal and electrical energy. Another is that every cement industry, depending upon the type of the kiln, whether you have 4-stage or a 6-stage, you have a potential of 25% of your energy, electrical energy requirement, you will be able to use from your own waste heat. And old plants, you can have potential of 35% of the energy you can generate from the waste heat, and new plants can have a potential of 25%. So this indicates that the when we talk about a PAT, which is the most innovative thing in terms of the methodology, which we being a Swiss parent company with operating close to 70 countries across the world, when we try to share this methodology, they say this is the best document which actually the Government of India and Bureau of Energy Efficiency has generated. There is no such a comprehensive approach in any other country document in terms of the PAT document what has been generated. We are able to address the oil, we are able to address the thermal energy, electrical energy, bring the total energy, what is being consumed by the plant. I think that's a very, very innovative step which ultimately able to tell you what is the type of financial impacts every 1 MTOE we are able to reduce the energy. So waste heat recovery is one of the big levers which we have for every plant. Wherever the kiln is there, you have potential to reduce that much of coal which you are bringing for the CPP, which you can avoid. Another one is the alternative fuels. India is having a 75 million tons of waste heat generated in the urban towns, all the cities. These 75 million tons, if they are able to substitute 40 million tons of coal, which we are importing from overseas, we can prevent it by using the waste. So the cement industry, what this PAT mechanism has done is that the PAT has said that if you are using the waste in cement kiln, you will be considered that energy as zero. So which has actually triggered the initiative in the innovation in all the companies, trying to create a feeding systems, processing platforms, how to use RDF, what are the methods in which we can improve the process of the cement kiln, that we will be able to accept the industrial waste from the other industries and also take the municipal solid waste into the cement industry. Another one is the electrical energy, which all of you know that in terms of MTOE, 30% of the energy is electrical energy contributes only to 30%, 70% is the thermal energy which contributes. Still there is a huge potential in this, and many times we forget that when we do this audit, we found that the leakage arresting is the biggest lever for any plant. Arresting the leakage and MTBF, mean time failure, between the failures. If you are able to increase the failure rate, reduce the failure rate of the plant and increase the mean time, what you are able to see, and that's a very good potential to reduce energy. Another is PRI, production rate index. You run the plant at the peak rate when you don't have demand also, shut down the plant and run the plant at the with less hours, but always operate at the peak capacity, which ultimately will be able to bring down your the specific energy consumption. This is what we found that many times we see that the CAPEX initiative is going to bring down the energy, the process optimization, running the plant always at the peak capacity, running for less hours, and also trying to avoid the leakages in the system. If I have a boiler with 11% oxygen, where I try to bring it down to 5%, there will be huge reduction in the heat rate and also in the auxiliary consumption. Another is about the logistics. Within the plant boundary, you have a lot of logistics, how you would like to reduce this logistics energy requirement. And your buildings, whatever within the gate, whatever the buildings are, if you are able to transform into a green building, your energy and air conditioning load requirements also will come down. So looking into these levers, when we start working on it, we thought the best way to approach this is a system approach. Try to create a communities of excellence. What we have done is, we have identified 7 levers. These 7 levers, we wanted to improve the target. First of all, we need to know the baseline. What is the best value in this particular thing, what we can achieve, what is the gap, and do a gap analysis, and how to see that the same process is there in every plant of ACC, how to keep the people of the same area who are working in all the company, all the plants, make them as a community of excellence groups. One for the clinker factor, one for the AFR, one for the CPP heat rate, one for thermal energy, one for the electrical energy. And these people meeting together and conduct the boot camp and make them to put the ideas together. So each plant had the one island of excellence in one area. And if that excellence is implemented in all the plants, definitely your energy is going to come down. And you can bring the suppliers into their knowledge and also try to get the global best practices in the process that with the low-hanging fruits. I am saying this 8% energy what the company has reduced is not spending CAPEX. Actually trying to replicate the best practices in each plant, what each plant, one plant has done, one best practice, repeat in all the plants. So this approach of is actually helped the company to bring down the energy. So 8% energy reduction means a cement company, the energy cost is close to 50%. If you are able to attempt a 8% reduction, it's going to make a substantial impact on the profitability of the company itself. So this is the clinker factor improvement. Today, I am very proudly to say that whatever the Government of India, Bureau of Indian Standards has indicated, this is the maximum amount of slag you can reach, this is the maximum amount of fly ash you can add. You have reached theoretical limits, what has been actually set by the government by the working with the quality departments and doing the product innovation. And in the process that we could save the raw material for the country and reduce the CO2 emissions, and in the process you could bring down the cost. So clicker factory is one of the big levers. What all that we have done, we have the many things which finally when these slides will be shared with you, you'll be able to go through and develop the products which actually reduce your energy intensity. It is not that I'll put a variable speed drive and I'll do. You need to do innovation on the product side, process side, product side. So and we come out with many products in the last 3 years which actually have a low energy intensity and low CO2 intensity. And a lot of products which we are actually indicating which had the high recycled content, low energy and high recyclability. And every product, any company produces the product, we see that how much recycled content you are using in the manufacturing the product, whether your product can be recyclable at the end of the life. So these things have been elements which have been used actually while developing the products. And waste heat recovery, which I said is one of the big lever for the cement industry, and we already commissioned waste heat recovery in one plant and other plants are on the verge of ordering. So AFR, which I mentioned, that is a big lever for us, where today I can say that we are almost close to 100 waste streams from different industries. You can say that cement industry is the national scavenger. You have a waste of fly ash, slag, or you are coming from the paint sludge, you are coming from the UTP sludge or municipal solid waste, any type of waste, cement industries today is able to showcase that we are the national scavenger. We can not only reduce emissions, we reduce the emissions of others. So this is something has been actually demonstrated by the entire cement industry. I am not saying that it's only the ACC, it's every company in cement industry has done a fantastic job. We are disposing hazardous waste, non-hazardous waste. We are able to do municipal solid waste, agro waste, biomass, energy plantations. If you have more than 100, last year we disposed close to 650,000 tons of waste in our cement kilns. Otherwise, could have been an environment hazard for the country itself. And the type of waste which you can see, the type of UTP sludges, large solvent, whether it is a liquid or a gas or it is a sludge, any type of waste which can be safely disposed in cement kiln because of the operating at 1400 degrees temperature. And going for the energy plantations in the dry lands of the mines where we are not able to use, and at least during the mine life you will be able to produce some energy and ultimately use in the cement kiln. How the energy intensity has been brought down by different plants. So these are the graphs related to that. And what are the measures which we have done in terms of, one, I would like to say the thermal energy. I said air leakage is one of the major elements. Second thing is the element which is related to the combustion reactions, or what is that you are able to do. Can you use less amount of fuel for burning? Means it requires burning your temperature optimization, using mineralizers, reducing the burning your temperature so that you can reduce the heat rate of the kiln. And also you are able to use the recovered heat from whatever is coming from the material and from the flue gas. If you are able to recover for, you can do for air conditioning, waste heat, whatever is coming, you can preheat the water. Many methods in which you can recover the waste heat, whatever is coming from the process. Improve the burners, and these are not very high cost initiatives, but we are having like many of the initiatives we found that are less than 1 year payback. Some are 3 months payback, 4 months payback. And in the process that thermal energy initiatives, unless the previous speakers who spoke about that going for a 4-stage to 6-stage, which is a capacity intensive and the time consuming process, but there are many more low hanging fruits are lying in each plant to reduce the heat rate. So I think in terms of one of the idea which I would like to say that the CFD, computational fluid dynamics, is one of the lever which actually going to bring down your process pressure drops of all the systems. If you are able to go for I think I can say that there are at least more than 200 systems where ACC has gone and implemented the CFD study of all the ducting. Because in cement industry, general process is that the material is going to settle, people are going to have ducts which are not going to have any settlement, no horizontal ducts. In the process that we have large amount of pressure drop, when we do carry out the CFD study for the mills and for the preheater tower and for the ducting, we found that there is a large amount of potential to reduce the pressure drop and able to reduce the electrical energy. My other colleagues who have mentioned already about the variable speed drives, efficient compressors, efficient lighting and efficient motors. There are many things which ultimately, which all of us know about capacity bank and using the unity power factor, all these are there. But there are some low-hanging fruits in each plant which normally have a much more bigger potential than the other major capex intensive processes, what we actually adopt. And then Now, since this particular PAT system has given such an opportunity that we are able to use renewable energy, the attempt is to reduce the energy intensity, but at the same time, if you are able to reduce the fuel consumption, electricity generation within the plant by using the green energy, there is an opportunity for you to reduce the part. And in the process that we have already installed close to 90 megawatts of wind stations in 3 states, and we are in the process of putting the plants in terms of within the plant boundary. If you are able to do a renewable energy project in your waste mine lands, solar is something which can be done in the cement industry in the mines, where we can install the solar power, which ultimately going to bring down the energy intensity at the gate. Logistics is something, large amount of oil is consumed in the mining equipment, also in the internal transportation equipment, and we are able to use the catalyst, fuel catalyst, where we can improve the efficiency of the all the mining equipment and the vehicles in the process, that the oil consumption can be brought down substantially. And also use the mechanized conveying system, where we can ultimately avoid the large amount of liquid fuel consumption. And the green buildings, the ACC is the first company in India put up a platinum rated control room in a new cement plant which is built near Chandrapur. This is a LEED platinum rated control room, where it had the lowest specific energy consumption in an industrial control room. And we have this particular thing has been done for the offices and other places, but what is unique about this is that you can bring down the energy of your building by going for a green building within the plant boundary. So, in terms of, I don't like to get into the other areas where we are able to contribute. What I would like to say is that energy reduction is something is related to, is a habit. And if you are able to transform the people about the mindsets in the plant, like you have a plant with 20 energy champions in each department, go for a level of, our approach is L1, L2, L3 approach, means you try to do benchmark the values, do the section-wise analysis, and do the drive-wise analysis of benchmarking. When you do a drive-wise analysis of benchmarking, you know the gap. That is the time where you will be able to really improve you can able to achieve the lower energy return. Otherwise, he says, I have a plant which ultimately may be the best number, but in some drives, I may be more. So that is the one which actually gives me the opportunity to reduce further. So thank you very much, and we have 3 more presentations to make. So I will ask the speaker, Mr. Sundara Raman from Seshasayee paper, to make his presentation. Big leap for the cement industry, and we already commissioned waste category in one plant, and other plants are on the verge of not ordering. So AFR, which I mentioned, that is a big lever for us, where today I can say that we are almost close to 100 waste streams from different industries. You can say that cement industry is the national scavenger. You have a waste of fly ash, slag, or you are coming from the paint sludge, you are coming from the ETP sludge or municipal solid waste, any type of waste. Cement industries today is able to showcase that we are the national scavenger. We can not only reduce emissions, we reduce the emissions of others. So this is something has been actually demonstrated by the entire cement industry. I am not saying that it's only the ACC, it's every company in cement industry has done a fantastic job. We are disposing hazardous waste, non-hazardous waste. We are able to do municipal solid waste, agro waste, biomass, energy plantations. If you have more than 100, last year we disposed close to 650,000 tons of waste in our cement kilns. Otherwise, could have been an environment hazard for the country itself. And the type of waste which you can see, the type of ETP sludges, sludge solvent, whether it is a liquid or a gas or it is a sludge, any type of waste which can be safely disposed in cement kiln because of the operating at 1400 degrees temperature. And going for the energy plantations in the dry lands of the mines where we are not able to use, and at least during the mine life you will be able to produce some energy and ultimately use in the cement kilns. How the energy intensity has been brought down by different plants. So these are the graphs related to that. And what are the measures which we have done in terms of, one, I would like to say the thermal energy. I said air leakage is one of the major elements. Second thing is the element which is related to the combustion reactions, or what is that you are able to do. Can you use less amount of fuel for burning? Means it requires burning your temperature optimization, using mineralizers, reducing the burning your temperature so that you can reduce the heat rate of the kiln. And also you are able to use the recovered heat from whatever is coming from the material and from the flue gas. If you are able to recover for, you can do for air conditioning, waste heat, whatever is coming, you can preheat the water. Many methods in which you can recover the waste heat, whatever is coming from the process. Improve the burners, and these are not very high cost initiatives, but we are having like many of the initiatives we found that are less than 1 year payback. Some are 3 months payback, 4 months payback. And in the process that no thermal energy initiatives, unless the one, the previous speakers who spoke about that going for a 4-stage to 6-stage, which is a capacity intensive and the time consuming process, but there are many more low hanging fruits are lying in each plant to reduce the heat rate. So I think in terms of one of the idea which I would like to say that the CFD, computational fluid dynamics, is one of the lever which actually going to bring down your process pressure drops of all the systems. If you are able to go for I think I can say that there are at least more than 200 systems where ACC has gone and implemented the CFD study of all the ducting. Because in cement industry, general process is that the material is going to settle, people are going to have ducts which are not going to have any settlement, no horizontal ducts. In the process that we have large amount of pressure drop, when we do carry out the CFD study for the mills and for the preheater tower and for the ducting, we found that there is a large amount of potential to reduce the pressure drop and able to reduce the electrical energy. My other colleagues who have mentioned already about the variable speed drives, efficient compressors, efficient lighting and efficient motors. There are many things which ultimately, which all of us know about capacity bank and using the unity power factor, all these are there. But there are some low-hanging fruits in each plant which normally have a much more bigger potential than the other major capex intensive processes, what we actually adopt. And then now since this particular PAT system has given such an opportunity that we are able to use renewable energy, PAT the attempt is to reduce the energy intensity, but at the same time, if you are able to reduce the fuel consumption, electricity generation within the plant by using the green energy, there is an opportunity for you to reduce the power. And in the process that we have already installed close to 90 megawatts of wind stations in 3 states, and we are in the process of putting the plants in terms of within the plant boundary. If you are able to do a renewable energy project in your waste mine lands, solar is something which can be done in the cement industry in the mines where we can install the solar power, which ultimately going to bring down the energy intensity at the gate. Logistics is something, large amount of oil is consumed in the mining equipment, also in the internal transportation equipment, and we are able to use the catalyst, fuel catalyst, where we can improve the efficiency of the all the mining equipment and the vehicles in the process that the oil consumption can be brought down substantially. And also use the mechanized conveying system where we can ultimately avoid the large amount of liquid fuel consumption. And the green buildings, the ACC is the first company in India put up a platinum rated control room in a new cement plant which is built near Chandrapur. This is a LEED platinum rated control room where it had the lowest specific energy consumption in an industrial control room. And we have this particular thing has been done for the offices and other places, but what is unique about this is that you can bring down the energy of a building by going for a green building within the plant boundary. So in terms of, I don't like to get into the other areas where we are able to contribute. What I would like to say is that energy reduction is something is related to, is a habit. And if you are able to transform the people about the mindsets in the plant, like you have a plant with 20 energy champions in each department, go for a level of, our approach is L1, L2, L3 approach, means you try to do benchmark the values, do the section-wise analysis, and do the drive-wise analysis of benchmarking. When you do a drive-wise analysis of benchmarking, you know the gap. That is the time where you will be able to really improve you can able to achieve the lower energy return. Otherwise, he says, I have a plant which ultimately may be the best number, but in some drives, I may be more. So that is the one which actually gives me the opportunity to reduce further. So thank you very much, and we have 3 more presentations to make. So I will ask the speaker, Mr. Sundara Raman from Seshasayee paper, to make his presentation.
Thank you, Chairman. Thank the delegates and the experts who are assembled over here. I said this is going to be the first time I'm going to speak for all the common 8 sectors. Because whatever you shared, and it is not only for paper and pulp. What we have done in paper and pulp, I thought I'd disseminate to all the other sectors who can, what we call, come out with, at this time of need of the PAT which is going strong, can help you in reducing your specific energy consumption. So some of the, I'm going away from the normal practice of the standard one. Most of the things are going to be innovative, being done right in the plant. And I'm happy to say that we are diagnosing basically back from here to the other countries. So basically, as I said, the pulp and paper being, the cost of paper going down, or the pricing, definitely there was an opportunity to come down. One of the major factors is the energy cost. So long before the patch has come into being, we were doing the way of life is reducing the specific energy consumption, be it on the power side, electric side, or the thermal side. So the emission, what I mean is the carbon emission in the international stage. So we are going to share with you some of the case studies on the innovative studies we have done, basically on the improving energy efficiency or the energy conservation or going into the cleaner fuels. And one of the most important areas is the cycle efficiency of any of the thermal power plants. And of course the in-house biomass power generation, which of course the fat clearly grows on the G to G basis. And the black liquor solids has been identified as one of the prime renewable energy going into the GHG and ACC reduction. And of course, as my predecessor, chairman, was talking more on the waste, what are the areas the waste can be converted. So here I just directly related to the energy efficient innovatives we have done. The first and the foremost is the captive power plant we have. It's a 105 bar, 1500 psi high temperature power plant, which is a 21 megawatt, wherein I talk about how we had improved on the cycle efficiency by increasing the power generation by what you call, normally all of us are aware that the vacuum is a very important point when you do the condensing, extraction condensing or the condensing as such. And beyond that we have gone into something what is specific in the dryness fraction. If you see the condensing, the whole cycle efficiency is lower because of the lot of heat rejection which is otherwise not being efficiently utilized in the power plants. Instead of rejecting the heat, I improve on the vacuum in terms of the dryness fraction. Basically when you contemplated with BHL for the turbine, we went to the dryness fraction which was as low as 89%. I think that is which means 10 to 11% of the latent heat is available for the power. And there we have automated the system in that a continuous monitoring of the dryness fraction measurement has been done. That's the first time I think in the country, possibly in the world, where the dryness fraction is continuously monitored and make the dryness fraction as low as possible and converting that steam and water in terms of power. This is actual, I think, definitely when the monitoring verification comes, it's a snapshot which is going to guide us. You see the real snapshot we find, the dryness fraction is always maintained well below this 90 to 93 and hovers on 85. So which means all the time we are going to convert to 10 to 15% of the heat which is otherwise lost into active power. So the real effect what we are getting is about 0.4 to 0.5 megawatt power, which is 500 kilowatt every hour, which has been done for the last 3-4 years on a continuous basis with a continuous monitoring of the dryness fraction. How we can do it in a small sense, if you can translate it to a thermal plant which is 500 megawatt, recently I studied the NTPC, you have 500 megawatt operating the dryness fraction of 93-94, coming down to 90%, can really get you another 30 to 40 megawatt, 20 to 30 megawatt extra power. Instead of realizing, I was telling Honorable Minister the other day, he is contemplating a 10% reduction in the whole power plant. I said this could be very well achieved if you can go in for this concept of reducing the dryness fraction and improving the power generation. The next one what we did, along with Metso automation US, they have done it for the power plants for the relays. We have done for cogeneration in terms of directly fuel to the power. There is the pressure incremental upgradation or swing has been reduced by what is called the direct energy balance, which has been conceived out here. And this is being very well used not only here, but also in the US. And based on this, we are able to save about 0.15, 0.2 megawatt on a continuous basis on our plant. The second one as the waste. The LOI of